Welcome to the Fireside Chat in the afternoon. I hope we're able to entertain you. This actually is not about me. It's about the first Fireside Chat is with three startup founders. But although they're startup founders, it's on one hand about startups, but they're all deep technologists as well. So I hope we can keep the conversation mostly on the technology side. And I'm sponsored by Mountain Dew. Yes, it's been a long day already. I'd like to invite on stage first Elliot Horowitz, the CTO of MongoDB. Thank you, Elliot.
Thanks.
So you've been with Mongo as a founder.
As a founder.
As a founder, you were with DoubleClick in the past, and after ShopWiki as well. So a long history in building the technology side of young businesses.
Right.
Yeah. I think for anybody that is any technologist knows all about Mongo. I think Mongo is a very popular database for anybody to use. Many of our customers on our platform are using us. But just for those who may not be completely in the know, can you give us a bit of a rundown of what sets Mongo aside from other non-relational as well as from relational databases?
Sure. So the key thing about MongoDB, in my mind, really is the data model, right? So MongoDB is a document database. So instead of storing data in tables and rows, you're storing it in documents. And they're JSON-like documents where you have arrays and nested attributes, and you can do all sorts of things with it. And one of the key things that we started doing in the beginning was, all right, well, it's great that you can store this JSON blob in a database, but the thing you really need to be able to do is then do interesting things with it, right? You want to be able to index embedded arrays and do complex queries on subsections of it, or maybe update small sections of it, atomically with some sort of transactionality around sort of modifying multiple fields in a single document. So it's really all about figuring out how a document sort of fits into modern programming and how to make developers more productive. And then also on the operational side, making sure that it's horizontally scalable, which comes a lot from the data model itself, and making sure that it's horizontally scalable, making sure that it's easy to do high availability and get durability across multiple data centers, and do a lot of those things that make sense in sort of modern deployments.
So you've been really known actually for doing that side of your business, that side of your technology really well. I mean, replication, sharding, things like that are hardcore. I've actually often heard from customers that was the reason why they started using Mongo much more than the document model. Is that something that you guys have seen as well, or is the document model the key driver?
So it's both. I think a lot of people like the document model, and a lot of people like sort of horizontal scaling. Replication is a little bit special. We can talk about that for a second. But one of the key things to remember about horizontal scaling is that the document model is what allows it. Right? By using documents and by sort of putting like data together, by putting all the user profile together in a single document, that's what sort of enables real horizontal scale. Right? That's what lets you do sort of transactions at a document level on a single node and then scale that horizontally. So you really can't have the scaling without the document. Mm-hmm. And then on the replication side, I think it's just a modern implementation of replication. And I think some of the key things that have changed, like for example with AWS. With AWS, durability on a single node is not something that is sort of the be-all, end-all anymore, because nodes are a little bit ephemeral and you sort of don't want to care about a node. You want to care about, hey, when I do a write, I want to make sure this write has replicated not to just one node, but to maybe 2 nodes or 3 nodes, and maybe just not 3 nodes, but I want it to be in 2 different data centers, maybe in 2 different continents. And you want to be able to tune these things so that you know when you do a write that it's actually safe, it's actually committed to enough places that it's safe so that you can treat machines as completely ephemeral and stop worrying so much about whether a machine is up or down.
So one of the things that actually, I don't know whether you're here this morning for the keynote, but I really talked in the keynote about as well, is that performance is one of the other drivers. It's not just reliability, it's not just being able to split up your database into multiple shards, but also that often customers, definitely those that have to run large clusters of whether it's Mongo or Cassandra or others, often have to do this to actually get the aggregate I/O out of it. Yeah, is that something that you guys are seeing as well? Because what I've noticed is that quite a few of our customers, before we had the SSD instances, they will really had to go to maybe even 30 or more nodes to get the aggregate I/O. Is there something different in this style of databases that make them more sensitive to I/O performance?
I don't think they're more sensitive to I/O. I think that one of the reasons why people use a non-relational database is because they're trying to do a lot of writes and a lot of transactions. And so I think those applications just sort of naturally lend themselves to doing lots of I/O. And then I/O is sort of one of the things that has always been hard to scale up vertically because you can't put that many physical hard drives in a single machine. Mm-hmm. But it is changing a little bit now. SSDs have changed things a lot. Fusion I/O has changed things a lot. We have a lot of customers or users who actually can put a couple of Fusion I/O drives in a machine and do quite a lot of capacity with a single machine that way.
Okay, so do you see sort of a trade-off between, so what I've seen customers do is going for these larger clusters, which then actually automatically also gave them a level of higher availability. Those that actually kind of start shrinking their clusters and only start using a few machines but with SSDs in them. Is there a threat towards reliability then as well, or?
So with Mongo, you sort of have two different scaling vectors, right? You can scale out the number of shards to get sort of more I/O, more CPU, more RAM, and then you can scale on the availability side how many nodes you have per shard. And so a small number of shards doesn't really change reliability very much. And so from our standpoint, it doesn't really matter if it's a big cluster or a small cluster. It's just a matter of sizing the cluster for what you want to do. And also a lot of people use larger clusters not only for scale, but also for data locality. Right? If you've got users in the US and users in Europe, and you want to have local writes, you can do things like partition data, and Mongo has features to do this automatically based on where people are coming from. And so there's lots of reasons to have larger clusters or smaller clusters.
Okay. So SSDs are really important for me because I've heard that, if I hear from customers that actually have their own data centers or the clusters there, I hear from them that they're equally looking to run Mongo on SSDs preferable over magnetic drives. Is that something that I'm right in, or is it?
Yeah, from our standpoint, SSDs really completely changed the game for databases, right? It's sort of so many of the things that are problems with spinning disks sort of almost automatically go away with SSDs. And people see, anywhere from, a couple X to just massive improvements with SSDs. And then regular SSDs up to Fusion I/O, up to all these things, it really has a pretty profound impact on databases and what you can do with a database and sort of manageability, just keeping it simple and easy to work with.
If you look at the workloads that your customers are running, are there particular sort of buckets that stand out? Sort of, is it more the web apps? There's a lot of big data? Is there a lot of analytics?
Yeah. So I think one of the interesting things about Mongo is there aren't too many verticals that it's sort of the thing for. It's pretty broad. So we've got a lot of use cases. Some common ones are sort of user profile management, that sort of thing, where you sort of have a bunch of information about a person or about a document. So CMS is very popular in the CMS space. We also see it a lot in logging applications or sort of click tracking, those sorts of applications where it's a lot of high write volume, high throughput, lots of little writes. We've sort of got to aggregate these things. And then we also see it in offline applications, right? We've got people like Apple using it for things like iTunes gift card reconciliation, where you're actually going and verifying gift cards with it. So it's sort of pretty broad spectrum.
Okay. One of the things you've been in the news lately quite a bit. I think one of them is with your latest funding round. Actually, congratulations on that. I think you're probably now the best funded company in New York, at least.
That is what I hear.
But I think it's probably public knowledge that was $150 million.
Yep.
What are you going to do with $150 million?
So really two things, right? One is, we're sort of growing internationally a lot, sort of building a lot of team there. And two is just, and the big bulk of it is really just investing in the product, right? We've got a pretty big engineering team that needs to grow a lot more. There's sort of an infinite amount of things to do, right? If you think about the database space as a whole, right? Mongo is still a very new product in the space, right? If you compare it to sort of Oracle and Postgres, these things are a lot older, and a lot of this technology takes time to mature. There's a lot of features, a lot of generational things where you need to do not version 1, but version 2 and version 3. So a lot of work to do there. We have a lot of work to do on operational tools and sort of making tools for people to manage very large clusters very easily. So we really want to invest a lot in those tools, right? People, with a 3 to 12 node Mongo cluster, it's very easy to manage. When you get into 500 nodes or 1,000 nodes, it becomes pretty complicated to do like a rolling upgrade. You want to upgrade like 1,000 nodes without any downtime. It's a little bit tricky today, and we want to make it really easy. So sort of a lot of work on the core database, a lot of work on the infrastructure, and also a lot of work on integrations with different other products that people want to use MongoDB with.
Okay. So the origin of your company, or at least you guys have an open source. It's an open source product, in essence.
Yes.
What makes it? There must be. What are the particular challenges of building a company that operates on an open source stack?
Well, the number one challenge is that people don't generally want to pay you. But
yeah, I don't know. I heard this great in past was this nice quote that open source is not free as in free beer, but free as the puppy that your kid brings home.
Yeah, so it's like that. But on the other hand, I don't think in this day and age you can actually build a database that is sort of widely adopted that's not open source. I think it makes a lot of sense that infrastructure software should be open source, right? No one wants to bet their entire company on a product, and especially a startup, and if that thing goes out of business, sorry, you don't have anything to do anymore. So I think, open source clearly is the right model for a lot of these things. And then the onus is on us is to figure out how to add things that people are willing to pay for without actually, making it sort of tough for people to get started.
Yeah,
right.
But without talking about, actually I was thinking more about the technology side of this. I mean, how do you as a company manage the fact that to take in, let's say, change requests or to take in contributions by others? Is there a particular stricter methodology for taking changes in, or do you just trust the committers by themselves, or?
So most of the core committers are MongoDB employees.
Okay. And
when we get submissions, I'll be the first to admit it, our sort of lead engineers are pretty tough about code reviews. So definitely we've turned a few people off by being a little bit pedantic about like, nope, this is not good enough. But I think we treat external contributors the same way we treat internal contributors, and this is a very high bar. If someone meets that bar, we let the code in. But I think we do a pretty high bar on code, both internally and externally. A lot of onus on code reviews and testing, so that really do try to keep the quality very high and also always improving.
Yeah, I recently talked to Sebastian from Scalar, who basically have a product that also is based on open source, and he said that one of the biggest challenges that they had with, for example, selling to government agencies was that government agencies wanted to know exactly who had contributed which piece of code, and that there's a clear distinction between what the company had done and what public committers had done.
Right. So with Git actually makes it a little bit easier. You've got a really nice history there, and we do actually make sure that committers actually sort of sign over copyright to us, so we can actually give someone something that they know is clean. Right. That is sort of an issue, and that was an issue with Linux early, and I think it's become less of an issue where people want to know that the pedigree is clean and that they aren't going to be encumbered by sort of weird patent lawsuits and sort of things like that. And we do a lot of work to make sure that the history is clean and we know where stuff comes from. We do make sure that we don't, someone doesn't accidentally put something that they're not allowed to put in there.
We at Amazon or at AWS, we love Mongo. Why? Because most of our customers actually love you guys as well. You're a very popular product. What have you seen as the challenges that our customers have with running Mongo on our platform? What is the challenges that may be different with others? And why don't we tag on that the question, what could we do better to make sure that you can run better?
So this is an interesting question because it's actually changed a lot over the last few years. Right, so if you look back 2 or 3 years ago, before you had SSD instances, before you had priority IOPS, people had a lot of trouble then because you were running Mongo on sort of regular EBS instances, regular EBS volumes, and at that point, Mongo's concurrency wasn't as good as it is today. So there was sort of this perfect storm a couple of years ago where you had EBS that wasn't maybe the most reliable or the fastest thing. You had Mongo concurrency, which didn't handle slow disks very well, and you had this perfect storm of things that were terrible. So that was actually probably one of the biggest challenges, and now that's actually greatly improved both on our side and your side. We've improved our concurrency a lot over the last 2 years, and with priority IOPS and SSDs, that's changed a lot. I think the biggest challenge that remains is that a distributed database is a fundamentally harder thing to manage than a single database. Right? When you're deploying a Mongo instance, you are not deploying one node, you're deploying dozens or hundreds of nodes, and that has some challenges. There's one interesting one, which is related to security. So people bring up Mongo instances and they bring them up and down pretty often, right? They treat them ephemeral and they can use replica sets, so that, that's how they handle the availability and durability. And so they bring nodes up and down. And we have this monitoring service that basically lets us monitor your applications. You download this thing and it monitors your Mongo servers. So the interesting thing is what happens more often than you'd imagine is someone is monitoring some Mongo server. They take it down because they're done with that box. Someone else brings up a box. It gets the same AWS IP address, and they don't set up security correctly, so it's open to the world. So our agent starts, continues to ask it, hey, how are you doing? And it now thinks it's part of the old cluster. So we'll have people who sort of get these merged clusters because they don't have security set up correctly, and you reuse the same AWS IP address, and now you've got these things all merged.
Okay.
So I think there are just challenges when you're dealing with databases that are, with sort of ephemeral instances and a large distributed product, right? And so I think security is a challenge. I think I/O is still a little bit tricky, right? People don't know whether to use SSDs or priority IOPS. I think it's a little bit confusing.
Okay.
And I think on your side, I think I think making that sort of more obvious, right? I think we've got to figure out what is the best way to deploy Mongo and making that really, really simple, because it is a challenge.
Okay. Yeah, actually, I've seen that especially in the Valley, being a Mongo or a NoSQL DBA is one of the highest paid jobs at the moment. That really gives you an idea that these things are hard to do. Tagging on the security stuff. So we for DynamoDB we recently released very fine-grained access control on basically on rows and then on items, where you can use IAM roles to actually to lock down the database for this person to only be able to access that particular piece. Is that a requirement that you guys, first of all, do you guys do something like that, or is it a requirement that you've heard for your customers?
Yeah, so actually the next version of Mongo coming out early next year will have something very similar, where you can actually lock down data based on a user's role and what's in the document itself. So you can sort of match a user, so you can actually store in the document attributes. And one of the cool things we'll be able to do is actually filter out subsections of the document, right? A user may be able to see the entire document minus this one field or minus this sort of recursive tree. So we can do some things like that, so you can actually trim out subsections of things.
Okay.
And it's a pretty big requirement for a lot of our larger clients.
Okay. Of course, the last question that I need to ask, because we have this framework where we today we release Postgres as managed by RDS. Many of our customers has asked us, can't you give us a managed version of Mongo? Whether you guys run that as a service or whether we run that as a sort of an infinitely scalable Mongo in RDS framework kind of service. Can we work together towards that?
On our standpoint, yeah, sure, let's do it. I think we see a lot of value in it. I think what's the programmer's dream, right? Is being able to just sort of take some code, throw it up into the cloud, and sort of have it work perfectly. It doesn't really work today, but you guys have a lot of the tools, and if you could take an Elastic Beanstalk instance and have it powered by Mongo, I'd use it a lot. And I think it's just a matter of getting maturity, and I think the more people who want it, so keep clapping. I think we should absolutely. But from our standpoint, it makes a lot of sense.
We definitely want it, because I know, as you hear, our customers want it. So whatever we can do to work together to get to that point, let's do it.
Yeah, no, that sounds great.
Thanks, Elliot.
Yeah, great. Thanks,
guys. Actually, I'd like to now invite an old friend on stage, a former Amazonian, Jeff Lawson, the CEO of Twilio.
How's it going?
Great, man. Okay. Jeff is a former Amazonian, a long-time, entrepreneur, actually. And it's very cool to have an entrepreneur that is so deep in the technology space, because you guys are probably one of the geekiest companies around. On one hand, I think, TwilioCon, you guys have your own conference, where really cool stuff is being built.
That I invited you to speak at.
Yeah, and if you do that, if you ask me that about 6 months ahead of time, then we
I'm
can make
asking you today.
Okay, good. When is it?
I don't know.
Talk to Lisa.
Do we have a date? What? Mid-September. Oh, mid-September.
Next year, mid-September.
Yeah.
I'm looking.
You're asked. We have.
I'm looking at the other side of the room, so we'll make a note of mid-September somewhere.
All right.
Now, so. I think I'm a great admirer of Twilio for a number of reasons. First of all, you guys are taking on a space that everybody hates. Yeah? No, I mean, who here loves their mobile provider? Telco provider? Any lovers in the room here? No. Why not? Because they're just hard to work. They're not programmable. You guys has taken on that world and not only make it programmable, but made it that simple. Just having one URL that's being called because an SMS comes in is just great. So how did you guys decide to take on that space?
Well, it's interesting. We sort of looked at our own experience, and my experience starting Twilio was I've been a serial entrepreneur. I had started 3 companies, and then was in AWS. And when I left Amazon, I had spent some time thinking about what I wanted to do, and I had this realization. I said, you know what? Each one of my 3 previous companies, we had wanted to incorporate communications into the products we're building, into the customer experience, into some part of the life cycle of doing business, like communications came into play, and we're software people, right? So we would look at how would we go about doing that. And it didn't make any sense to us, right? Because on one side, you're like, all right, we're software people. I know how to send an email, but making a phone ring, that's like magical. I don't know how to do that. And then you go out to look at the industry, right? And every industry has been turning into a software industry, right? And you see, you can program your infrastructure to build a data center. You can program all these sort of building blocks. And then you look at telecom. And this is one of the last industries that's saying, no, you're going to forklift in a giant black box, monolithic application, hardware, software, connectivity to carriers, and you're going to forklift this thing in and spend millions of dollars and spend 18 to 24 months implementing some enormous enterprise installation of some Cisco or some Avaya thing. And you're like, this doesn't make any sense to us software people, right? We want composable services, right? We want to be able to put those building blocks together to build an experience around what our product need is, and not go buy some big monolithic application, 99% of which we don't want, just because we want these little parts. And so seeing that there was no such concept of composability really in what people were out there offering in communications, we started Twilio to solve that problem, right? To be able to break down communications into its component parts and then let developers build those back up into the solutions that solve their business problems seemed like an obvious thing once we really looked at it and broke apart the problem and said, you know what, this is what's missing, right? Every other, in every other part of software, right, we embrace Agile, right? We have broken, who here does Agile as a development shop? I'm just going to pretend that that's 100% because it basically is, right? And it's like we've figured out as software people that you don't start off with an enormous project and then just sort of try to plan the whole thing top down and then embark on a 12-month, 18-month development process. No, like you start off with your idea, you break it down into sprints, you implement things that are adding value to your customer, but you assume that at the beginning you don't know everything perfectly, right? And that's, as development shops and as software people, that's how we've gone and built really everything that's great for the last 10 years. Now you go look at when you have to go turn to a big enterprise vendor, like you do in telecom. And what you do there is we're pretending back in that world for enterprises that, no, we know all the requirements perfectly up front, and we're going to go to a vendor and maybe submit RFPs, and then they're going to spend the next 12 to 18 months delivering a solution in the form of a big set of boxes to drop into my data center. And we all assume, oh, well, that's going to work out well, right? And what you've done is you've outsourced. You've taken a waterfall process and just dumped it on a vendor and said, oh, I'm going to have a vendor do this. And you're like, well, that doesn't make any sense. We have already figured out that as software people that doesn't work. Why would I assume that treating a vendor that way would work out any better? And in fact, it doesn't, because 70% of enterprise hardware and software deployments fail, never see the light of day. Why? It's because it's basically the waterfall process all over again. And so you get back to this notion of the composable enterprise and wanting building blocks for all the things you have. And Amazon is the perfect example of providing the right building blocks at the right layers of abstraction to enable developers to do really powerful things. And Twilio is doing that for the whole world of communications.
So let's go back to that Agile part. You don't know on forehand exactly what the end product is going to be. I mean, you know where you want to start with. You guys started off with, voice and SMS. So what were sort of the next steps that came after that? What your customers taught you that would go into version 0.2 and things like that?
Well, it's interesting. When we started with voice, we did not have SMS when we started.
Oh, okay.
So we started with voice, and we launched US phone numbers that you can make and receive phone calls from. And one of the first things that we heard, big customer demand was, hey, we want to do SMS on these phone numbers. Like, I can do SMS on my phone number on my phone. Why can't I do that programmatically with Twilio? We said, wow, that makes a lot of sense. And we went back to the carrier network and figured out how we could enable that for our customers. And an SMS has been a remarkably popular product for us, the sort of two-way SMS. And what's so interesting is after that, I'd say the next big thing, the next area that customers dragged us in was a global presence, right? So we started as a very, US-centric company. Why? Because that's where we were, right, of course. And what we very quickly found was that our customers are software people. And if you're a software company, chances are you either have a web application or a mobile application. You have a web application, you put it out there on the internet, and people from all over the world are coming and using it. If you have a mobile application, you upload it to an app store, and it's live in 120 countries overnight. Right? And so the boundary between geopolitical entities for software people is basically non-existent. Right? You send an email from your application. How many of you have an application that sends an email to a customer? Right? Do you have to care about what country that customer is in? No, you just send an email and it goes and the internet works, right? But if it's telecommunications, you're like, oh wait, I need to send a text message to a customer in Italy. Okay, now I have to go to business development with carriers in Italy for some reason, right? Like, it just doesn't make sense to IP-oriented software people. And so we set out to solve that problem because our customers were global. Even if they were around the corner from us in San Francisco, their customer base was everywhere in the world. And they wanted one API that they could communicate with any customer anywhere in the world via any channel.
So how does
and we set out to solve that problem.
Okay, so you solved that problem then. How does the pricing model works there? Do you have a differentiation between which country the SMS goes to, or is it just a flat service, a flat pricing model? Because the telcos will rip your arm off if you want to do anything internationally.
Well, it is similar. It's interesting. Like the US and Europe and many parts of the world have actually completely different billing models. And so there are different prices between regions. And we make it simple. We make it easy to expose how much that stuff is. And obviously, there's no technical difference between sending to different areas of the world. We smooth over all those technical differences, including like full Unicode support, right? When we entered the space, nobody SMS wasn't Unicode. And we were like, well, if you're communicating with customers in Japan, you're probably going to want Japanese characters. Yeah. Probably, right? And so we set about solving that problem. But from a pricing perspective, it's interesting. Like in Europe, the sender pays for everything. So if I send you an SMS, I pay to send it to you. And you receive it, and you did a passive thing. You receive something, you're like, oh, okay, that's free. In the US, the recipient pays. Actually, both parties pay. Right, if you receive an SMS, it goes against your SMS plan. And if I send you an SMS, it goes against my SMS plan. And so the economics actually between different continents and different countries is completely different. And so that is part of what we abstract with our API and make possible.
Let's go back to that API and that evolution of APIs, how things then change over time. But first of all, it's hard to run an API business. I mean, metrics, billing, all these kind of things are just hard. I mean, throttling, and we all know about it. So
I look at these guys with like A/B testing. They're like, where should the button go? Should it go here? And they can like iterate like on an hour-by-hour basis to make that better. I'm like, we put an API out and it's out there for the next 9 years. Yeah. There's no iteration allowed. I'm really jealous.
So building APIs is actually not as trivial as that it looks. I mean, you have to make sure that no denial of service attacks happen. You have to segment your customers. Tell us a bit about how hard that business is, or what are some learnings that people could take away with them for themselves?
It is. It's really challenging. And the biggest thing is, I mean, scaling a large web application, you do hit a lot of the same. And one of the things I often think about is APIs are very similar to scaling a large web application, and then in a few ways they are just very different. But what's nice is that all the techniques we have about scaling large web applications work for, say, a RESTful API fairly nicely. That's one of the benefits of REST. That's why we've all used it, because you have great tool chain reuse. But certain things are very different, right? You want to make sure, for example, multi-tenancy, right? If somebody is using Facebook and like they can't, some button isn't working because they have a multi-tenancy, like, okay, they'll get over it, right? But in an API company, maintaining perfect multi-tenancy is critical. And that really goes for any business-to-business like SaaS application, but an API as well, because it's even more important because as an API, it's not just you, but it's the entire chain of people who are relying on you that are affected by any imperfections in your delivery of quality, reliability, scale, and multi-tenancy, right? And so the effects are just amplified by any problems that you have. Because it's not just your customer who might be annoyed, it's your customer who's got Sev1 incidents filed against them by their customers, and like pagers are going off all over the place. And I'll admit, like we had a little screw up like 2 years ago. We were rolling out our international SMS, and we typically roll out major things in many small deployments. We deploy on average about 20 times a day. And so we'll deploy parts of an application stack over weeks or months even leading up to a major release. And we did a release that was not 100% backwards incompatible API-wise. It changed one small behavior that we thought would not be a big deal. It was sort of how messages got accepted for US delivery or Canadian delivery, something like that. Well, it turns out we did this one minor thing, and we learned this really big lesson. We found out that we set off pagers at 3 a.m. of DevOps teams across the continent, right? And you can imagine the earful our product managers and I got from customers. And like, we learned a tremendous amount about like how carefully orchestrated every little bit of your deployment needs to be, because this is not users clicking buttons. It is software that is mission critical for them, and that wakes people up and makes them deploy new code, or them, have conference calls to figure out what's going on, when in fact, like, no, Twilio did a deployment and, our stuff broke. So it's incredibly important, and that's something we focus so much of our energy on, is how to always deploy in a completely backwards compatible, completely safe way every change we do, despite the fact that we deploy on average about 20 times a day.
Yeah, the continuous deployment and continuous integration are in my eyes, very important tools, but still very hard to do.
Hard to get right, yeah.
Yeah, absolutely.
And I mean, that was one of the early reasons why we love to deploy on AWS, right? We adopted AWS in early 2008, and so we're fairly early adopters along those lines. Yeah. And one of the reasons why we did it, one of the early benefits that we got, was our ability to do testing automatically with clusters that looked exactly like our production cluster. Mm-hmm. Because you can completely script the notion of bringing up a cluster, firing load tests at it, and shutting it all back down, and pay about $1 and have a complete production environment up and running for the 10 minutes it takes you to do some sort of test. Mm-hmm. And that's amazing. That's something you could never do in the past when you were talking about physical infrastructure, right? How many companies have an exact size and state replica of their production environment?
Yeah,
nobody, right? There's always like, oh yeah, we have stage. Oh, but it's completely different in all these different ways, because no one's going to spend the millions of dollars it takes to have a production replica.
Or indeed testing your DR strategy.
Yeah, exactly.
For example, I mean, in the stuff that we talked about this morning in the keynote, all the new snapshotting and all the things that you do, you know what? You can just test it. You can just do it. Yeah. You can just launch your app in a different region and see whether it works or not. I mean, how cool is that? And I think also all the red-green deployment strategies, like, you just bring up a whole new web front end with the new code, flip the load balancer to it, leave the old one running.
Well, and you treat everything as ephemeral, right? Just like Elliot was saying, right? You treat every instance and everything as a disposable thing that can be reused as needed, right? And you assume like databases. It used to be databases were precious, right? It was sort of like all hail the database node, right? It was like the old mentality of this precious, 3-tier web application resource. And now every database in Twilio is ephemeral. We pivot them on a daily basis. We say, oh, we need to add an index, and that's an expensive operation. Well, we take our slaves, add indexes, and you imagine like a master-slave configuration. There's these slaves over here doing a new thing. The thing is done, and the software just goes vroom, and these are our new masters, and the whole pivot happens, and we do that every single day practically, and our customers never know it. And like, nothing is critical and nothing is sacred in an environment where you just have this engineering mentality. And it's amazing, because that's the right way to think about any kind of infrastructure. And AWS is the first vendor who's ever been out there saying, hey guys, we're all going to build better applications, and we're going to teach you how. And I love that.
Cool. Let's go back to the business of APIs. I mean, I remember Jeff at one moment hammering down on us that APIs are forever. Yeah, it's like, well,
that's actually, diamonds, I think.
Yeah. So he hammered. So this is something like, once you've put an API out there, it's very hard to change the API. I mean, doing next generations and things like that. So how has that been in your business? How is your thinking around, when you start off, you don't really know exactly how the API should look like. You figure something out, you do something. How do you evolve an API such that customers can actually continue to use it?
Yeah, well, we use a process, just like Amazon, working backwards. We have a process of working backwards, which is we write the API documentation first.
Okay.
So the very first thing we'll do is we'll write the actual public API documentation, not a functional spec or anything like that. And we take this documentation that looks like a finished product, and we'll float it in front of potential customers and say, hey, does this solve your problem? Does this look like it's the right set of tools? Because the observation was, as developers, when you go to, say, an API product, what do? You don't read the marketing jargon, do you? You go read the documentation. And you say, I'm going to figure out if this product solves my problem because the API has a call that looks like it does the thing I need to do, right? If you're like, I need foo, and then there's a thing that says do foo, you're like, oh, wait, this is going to work out well. And so we write the docs first, and that's a great way to get feedback from customers to make sure you're on the right path of building the right thing, right? Then you go build the minimal, the alpha, then you go build up, and then you release the GA, right?
Yeah, but if you have, let's say you have your SMS interface, that is sort of V1, but over time you realize that customers actually want more in that interface.
Oh, how do you add features?
Do you add features to the?
Oh yeah, all the
just
time.
version the interface and leave version number 1 running while you also have version number 2 of your, let's say, SMS interface.
Yeah, so we've got 2 versions. We have 2008 and 2010 currently live with Twilio.
Okay.
And it's interesting. So our most recent release is 2010. I just told you we release 20 times a day. And so most of the time what you find is that you're able to add functionality to an existing API. But over time, you end up with this backlog of like backwards incompatible things you weren't able to do. And then you make decisions to say, okay, now we're going to release a new API version where we're going to change those things and make something that's not backwards compatible so that we can sort of liberate the API from the previous constraints or previous assumptions and fix the things we don't like and enable the things that we couldn't enable before in a backwards incompatible way. And what we've just started to do is to talk about, for us it's been fairly ad hoc. We had 2008, we had 2010. We haven't done it since 2010, and this is now almost 4 years later. And so we started to say, okay, we're going to create a vehicle for a regular shipping timeline for a new version of the API. That way we know there's a train that backwards incompatible releases can hop on. And without that train, thank you to Brett over there, without that train, developers say, oh, am I always constrained? I can't make a backwards incompatible change, so I just need to throw away that idea because I'll never be able to do it. And we said, no, if every developer in the organization or every product team knows, here's the train, it's going to leave in 6 months, they say, okay, now I know how to ship that product.
Okay. Jeff, we're out of time, but there's one more question I want to ask you. What could we at AWS do better to make you run better?
Make it easier to get VPC up and running.
Okay. And combine that with making it easier to move from Classic to VPC. I know some of you...
Yep. We're all excited about VPC, but we all have huge clusters to move.
VPC is default for everybody now to use, but definitely we need to... it's feedback that you guys give us very loud and clear that we need to make it easier for you to migrate into VPC. Thanks.
Werner, can't you just go like that?
Thank you. Pleasure. Thanks. Good. I don't know if you guys read the keynote this morning. Remember that there was this one quote that says, we spend more on snacks than on DynamoDB? Let's bring up Valentino Folonghi of AdRoll, who actually is the owner of that quote. Yeah. Okay. So, what is it? Is Dynamo really cheap, or do you eat just a lot of snacks?
There's a lot of snacking going on in the office. 300 people take a lot of food.
Valentino, so your company's AdRoll.
Yeah.
That may not be a company that everybody might know here. So tell us a bit about your business.
So AdRoll is essentially the most widely adopted retargeting network that is on the market today. We have more than 10,000 customers in 100 countries in the world. And the basic idea behind retargeting is that most of the time when your customers visit your site, they end up not buying a product. And it's extremely useful, and actually it's easily measurable, that if you actually are capable of reaching over to these users once they browse on the web or on Facebook or wherever they go when they are not planning to buy something, then they actually come back very often, and with a measurable effect, they end up buying the product.
Oh wait, so you're the guys that are responsible that did Hipmunk ads.
That's correct.
Actually follow me everywhere.
That actually is one of our customers,
okay.
Yes.
Good.
Among every businesses of all sizes, and advertising has changed a lot. So this technology is extremely complicated to develop properly, not just because we do 100 billion requests a day on DynamoDB, but the sheer amount of business logic that goes into the algorithms for buying has made this type of technology never accessible to companies of all sizes.
Okay, so talk a bit about what are sort of the biggest building blocks in your business.
Yeah, so there's essentially a huge data collection pipe through which we, to this day, receive about 20 terabytes a day of data. And it's growing at it's growing by 4 times every about 4 or 5 months today, depending on what type of data our algorithms need. And then all of this needs to feed through all of our segmentation logic and algorithms for determining click prediction. on whether particular cookies are more likely or not to click on an ad. And then all of this needs to be controlled from a simple-to-use UI, because it's not just about processing all of this data, but it's integrating with tons and tons of other networks that provide internet traffic for us to buy. And this is extremely complicated for somebody to follow through all of these different steps. And all this complexity needs to be made very, very simple. And then all of this data needs to be funneled to our bidding systems, which are scattered around the world, and because they need to be extremely close to the source of traffic, because unfortunately the speed of light is incapable of making us fast enough to bid on traffic coming from Singapore, from San Francisco, where our headquarters are. So we actually need to
so what kind of latencies are we talking about?
So it depends on the network we work with. It varies between 50 milliseconds to 100 milliseconds usually, and it really varies depending on the region of the world. And usually that you don't even get that entire latency available to you, because there's network latencies that goes in between internet, there's AWS latencies within the routing and whatnot, and the ALBs. And so once it reaches your machines, there's a bunch of latency for you to parse the HTTP request, and you end up with 40 or 50 milliseconds. And increasing your latency by even just 10% means that you might, instead of timing out on 0.05% of the requests that are coming in, you're timing out on 1% of them. But if a billion requests every hour are coming over to your machines, then you're timing out on 10 million requests every hour. And that's a lot of lost opportunity at the end of the day.
Okay, so where's most of the jitter coming from in that case? Is it the network? Is it AWS? Is it your own processing? Or?
Yeah, actually, if there was one thing that I would love, would be to have a lot of transparency over what is going on latency-wise within AWS. Not just, part of it is maybe enabling 10 gig networks on standard machines and not just on cluster compute ones, but also just understanding. One thing is the latency that went through the ELBs, and then understand the latency internally within AWS will allow us to somewhat deploy have a strategy of deploying depending on the availability zones where we're getting better latency throughout AWS, and shift our instances around as the latency moves around.
Yeah, of more consistent latency.
Yeah.
That's for sure. They're really predictable in
Yeah.
that case. DynamoDB has been mentioned a few times. You guys are rock stars. In the DynamoDB world, tell us a bit about your usage there.
Yeah, so we at the beginning of our adventure with this type of real-time bidding on advertising, we weren't really sure what we were gonna use. DynamoDB wasn't out at the time. We were already fully inside AWS, so we went on this journey on trying to find the perfect cookie store. It's the way that this system is called internally. We went through a number of multiple options. Back at the time, there weren't SSD instances. I think Cassandra was version 0.6. MongoDB was still in version 1.0, I think, or very early versions. Redis was had no clustering and still doesn't. And we tried all of these, and we actually went through everything that you said today during the keynote, where you start to scale instances, not just because you need the computing power, but you need more storage, you need more bandwidth, actually. A big thing that we have is that Memcache is really super fast, but we need to scale to multiple instances because the number of requests saturates the network that goes to Memcache. So we need multiple machines just for bandwidth reasons. And the memory, the data that we store, we have about 2 terabytes of data stored in every region of DynamoDB. And that amount of data is only growing. And if you need to put together a number of machines just to aggregate memory and bandwidth, you end up with thousands of machines to reach up that same capacity, and that's not cost effective and doesn't help us in any way. So while we were doing all of our experiments, and I was staying up trying to figure out how to implement proper consistent hashing on top of Redis, implement all these strange clustering features, then DynamoDB was in private beta, and decided, let's try it. I write my own client in Erlang. That's our technology, and started to deploy, started to try it out. We started with 4,000 reads and writes per second provision throughput, and by the same time, a few months later, We were about 5 or 6 times that size in 2 different regions. And by the time the following year, we were 10 times bigger in 4 regions, and we had 0 operations people attached to this scaling. Elliot mentioned that scaling and managing very extensive clusters is very complicated, and it's totally, completely right. There are multiple things that go wrong, and none of those are necessarily your fault. Like Linux might have a bug, or there might be somebody that forgot when they were patching the Linux kernel to properly take care of the IRQ management of disks, and then there's deadlocks everywhere, and that machine crashes, and you can't hug your servers. That's something that you usually go with. You can't hug your machines, and so the best strategy is to rip them out and start fresh. But when you start to go to 1,000 machines, then you have a lot of inventory management of where your backups are, restore the backups as fast as possible, or have read replicas already available over there. And it's a lot of machines to
None of
manage.
that you have to do anymore.
No, nothing.
Yeah, so in comparison to what Elliot said, indeed, there's a lot of management going on if you have to run your own clusters. But one of the reasons the way that we did DynamoDB was really to make sure that you did not have to have a DBA that needed to fine-tune the machine for you under all conditions. So what are your typical read-write rates to Dynamo at the moment?
So we do about 80,000 reads per second per region.
Okay.
So that's
and those are consistent reads, or?
No, not consistent reads.
Okay, that's good.
So that's an aggregate of about 400,000, 360, 400,000 reads per second. And on the right side, we write about 40,000 writes per second per region. The funny thing, you mentioned also that the memory is the new disk.
Well, or at least SSD is the new disk. Yeah.
But that resonates with advertising, because in some ways it's a very wasteful industry, because the way that you do click prediction is pretty funny. You have this gigantic pipe of 20 terabytes of data that is growing at that speed, and you aggregate a month of this data in a single data store, and then you have these algorithms that essentially try to predict clicks using machine learning and run logistic regression models and whatnot. And these guys need to run in 1 hour, because an hour later, whatever they're predicting on is outdated. So you run this stuff. The shortest time they take to run gives you the most of the hour that you can use the prediction on. And then you apply the prediction on the following hour as soon as it's done. And then the new hour has come. Everything that you've done before is useless, and you can start from scratch. And if you don't keep on doing this regularly without ever failing on anything, then your competitors will beat you. Your competitors' algorithms will outperform you, and your data will not be as valuable to your customers as you thought it was going to be. And all of these things that are really, really complicated. The mid-market, the average customer that we have, so not necessarily huge brands, even though we have brands like Salesforce or Levi's that work on our platform, but we also have more medium brands like GoPro or Hipmunk that we help throughout their entire marketing strategies to reach their customers wherever they are going. And they need these algorithms to work perfectly without latencies, without having an ad that's loading up very slowly on whatever publisher site, and then when it loads up, it ends up being the Hipmunk site. And how that Hipmunk advertising really slowed down my browsing on the site, and branding is extremely important for all of that. So low latency is king.
Okay. Jeff, before you talked a bit about his development methodology and how, continuous integration, Agile, things like that, what is it that you guys do?
Well, that's very interesting, because we bring the concept of A/B testing, I think, to a different level. We have of the many strategies that we have, we usually need to develop these, and they're fairly complicated sometimes in order to get them deployed. And so what we have is an entire system that allows us to almost automatically deploy new strategies into a running system without having to worry about potential crashes of the systems everywhere. And this system will start to collect data with alarms in real time about whatever their behavior is going to be, if they're going to spend too much or too little, or if the clicks are not aligning with what the model prediction was thinking. And as the performance materializes and we reach some kind of statistical significance and we are confident that the results are fine, we automatically move into the A/B test system. And we do this by adding new machines, deploying the machines necessary to process all of the different strategies separately in isolated environments so we don't disrupt all of the work that is already happening that is working perfectly for now. And once we are sure that the strategy is working fine, then we roll it out to the entire system. And in one of our strategies, we go so far as to applying a genetic algorithm to what's happening on traffic in real time. So we split the traffic in 20 different buckets. We have different parameters for every one of those, and we let the genetic algorithm figure out how is every different variation of how I'm thinking that I'm bidding affecting the outcome of the performance of the campaign. And once we see the results coming back, this algorithm automatically kills some individuals, breeds the middle of the pack, and instead lets the top perfect race keep going on.
Something that you said earlier, well, I don't know whether anybody noticed it, but you said when you build a client for Dynamo, you did it in Erlang.
Yeah.
While you, at the same time, you were one of the founders of PyCon so what was the choice of Erlang over Python? And I think Erlang is a great language. Really, I wish we could use it more in more places. What we found was the hardest was that it's very hard to hire Erlang programmers.
Oh yeah.
No, yeah, I mean, there were some pieces of AWS, somewhere up the covers, I won't tell you which, are actually written in Erlang because we allow our engineers to pick the best tools for that they think are available for that job. Turned out to be really hard to hire more Erlang programmers that are really capable of building good systems. So what was the choice of Erlang there? Why? Or why, I mean, instead of Python, because you're one of the Python gods.
Well, first of all, we can hire Erlang programmers because we have a lot of snacks. So that's how we managed to get them into the door.
Okay, fair.
But no, so it's funny. So when I started working with Python, my first exposure to it was a web framework, an asynchronous web framework called Twisted Matrix. Mm-hmm. And it was meant to build networked applications, distributed systems, and that use the asynchronous paradigm that now is getting more widespread adoption thanks to Node.js. And when got to the point of implementing some of these high-performance systems in whatever language, I'm an engineer, so yes, I love Python, and there's a huge community in Italy and in general in the world that uses Python, but I'm about technology, so I want to see, is this the right choice for this specific job? And so I went through all the phases of testing. I built test systems in Python, in Erlang, in Java. I tried an extension of Nginx. I tried a couple of other systems, and what ended up coming out was that the Twisted system would have been almost comparable in performance to Erlang, but it would have required a lot more tinkering with load balancing. I would have needed to add a very specific version of the Linux kernel in order to do load balancing at the socket level or by using IP tables. And because just having an Nginx in front to do that type of load balancing would have been complicated. Plus, Python has problem dealing with multiple threads. And so it would have been complicated to share the gigantic amount of data that I need to fit in memory for those.
In looking at those different technologies, did you take a look at Go and at Scala? Were those options for you?
It wasn't there yet at that time. This was in 2008.
Okay,
so
good.
In 2008, when we moved this infrastructure inside AWS, Go wasn't around. Today, I think it would be a hard choice between Erlang and Go. There are definitely benefits to using either or. Mm-hmm. Go has a huge community and it's easier to hire people, especially you can train people very quickly from languages like C or Java or Ruby or Python.
Except that you have to still get them towards the functional mindset if you want to do the exploit things.
Yes, that's the part that Erlang kind of forces you to get into that mindset, and Go is still there, but you can still get away with some of bad practices that you don't want to have in your code.
Valentino, thank you very much for being a great customer, for giving me a great quote to use on stage, and thank you for your insights.
Thank you.
Pleasure. When will we be back? What? Oh, 3 p.m. Guys, half an hour. there will be a next session here with, yeah, well, I would say probably the top dogs out of the sort of investment world. Is that what you would say? I mean, David Cohen, the founder of Techstars, Ash, one of the co-founders of AngelList, and Albert Wagner, of the famous investors in probably almost every large internet startup. So please come back at 3 o'clock. Thank you.